Hello everyone, in this presentation we are going to understand how to interface a single switch with a microcontroller. So this is the 8015 development board. Here we have a port 0 which is connected to the 8 LEDs. Because it is pull up resistor is connected, all the LEDs are glowing at reset. So at reset all the port pins are in logic 1 state. So we have connected one switch. So there are 4 switches in this development kit. Among these 4 switches, one switch is connected to P2.0 as you see here. So this is P2.0, one switch is connected to P2.0 and the output is connected to LED. So the input is through switch through P2.0, the output is through LED through port 0, and the program is written in such a way that when you press the switch the LED blink. So as long as you press and hold the switch, the LED has to blink. Whenever you release the switch, LED has to stop. So this justifies how to interface a single key with a microcontroller. So whenever I press the switch, it produces a transition from 1 to 0. So that 0 is identified by P2.0 in the code, and then if P2.0 equal to 0, then the LED has to blink. That's why. So this is called controlled blinking, where as long as I press and hold the switch, the LED is blinking. When I release the switch, LED is not blinking. Okay, so this switch can be a sensor. Whenever sensor senses the blinking of an LED, notifies the corresponding parameter is being sensed. Something like that. For a number of applications we can use this concept for our understanding. Now look at this code for best understanding. In this code, as usual, we are starting our experiment with hash include reg51.h. This is very interesting. Bit addressing. Yes, bit is a syntax for bit addressing in a C program. We are giving a variable SW. So SW is a label, and then that label is assigned to P2.0. So whenever I say SW, it means that it is P2.0. So as usual, a small delay to overcome the persistence of vision, and void main, and then while 1. So this is the if statement. So whenever we press a switch, it produces a transition from 1 to 0. So when it finds 0, the LED will blink. When it finds 0, the LED will blink. So as long as the switch is 0, the LED will keep on blinking. When the switch becomes 1, the LED will not blinking. So this is what happening there in the corresponding kit. So this justifies this code and the experiment that what we did. This justifies I can able to blink an LED when the key is pressed. So keyboard interfacing first module is over. That means the microcontroller is responding to the key press is being justified and demonstrated here in this video presentation. This is how we have to start interfacing a keyboard with a microcontroller. If you look at the output, so as per the code, the 2.0 is connected to the switch. Whenever I press and hold the switch, LED blinking. So the controller is responding to the key press, and then it is blinking the LED. So this is how we can start interfacing the keyboard with microcontroller. Thank you very much.